Right. So first we want to finish our discussion on stacks and queues. Stacks we have finished. Queues, we did the implementation using arrays, but we did not do implementation using a linked list. Okay. So let's first finish that part. Okay, let me open my IntelliJ. Right. So we implemented circular queue using array. Okay. Array. So that means internally we keep the data using array. Right. So now we are moving to uh, how to implement the queue uh, using linked list. Okay, linked list. So last time we discussed about the queue operations, NQ, DQ, the limitation of linear queue. Okay, so therefore we moved with, because in linear queue, maximum number of NQs you can do is the size of the array. But if it is circular queue, uh, at a time you can keep maximum of the size of the array. Then that means when you dequeue, that space we can use for enqueue. Okay, that is the advantage. So that is why we wrap around. Uh, when you are at the end of the queue, if your front is still uh, available, you can wrap around rear to 0. Okay, so that is something we did. Right. So today we want to do the same thing using linked list. So therefore, first I will copy the linked list code. Okay. I will first copy the linked list code. Uh, Single linked list code. Okay. Node and single linked list. Right. So we had the node class that we can keep object and it links to the next. And of course, our add to head, add to tail, and so on. Okay. But in queue, there's nothing called add to head and add to tail because queue is where we insert to one side NQ and delete from the other side DQ. Okay, so let's visualize it. Now, how are we going to implement queue using linked list? So this is when you first insert something, say 10. So then this will be referring to null. So then when you insert another one, so remember we insert it to the rear, right? We NQ to the rear, DQ from the front. Okay, DQ from the front. So then this will be your new element and this is your rear and this is your front. And when you NQ another one, again, so you NQ to the rear. So this is your new rear. So you need to keep track of both rear and front because you NQ to the rear, right? Say let's NQ another one. So now this is your new rear. This is your new rear. But when you DQ from the front. DQ from the front. So therefore, when you DQ something, you take your front to the next thing. That's it. Because this will be garbage collected, right? Because no one is looking at this node when this is no longer your front. Right? When this is no longer your front, no reference is referring to this node. So if nothing is referring to a node object, that object is garbage collected. So likewise, we can keep NQ, we can keep DQ. Okay. Right. So first of all, you need the node class. Right. First of all, you need the node class. So then you need to keep track of uh, two nodes all the time. front node, rear node, right? Front node, rear node. So that means you need two references. So when you want to add something or enqueue, you create the node and take your rear to the next new node. When you dequeue something, so you simply take your rear one level to the, you traverse through the next and take your rear to this one because it will be garbage collected. So I gave you enough time for you to implement it. Okay, enough time for you to implement it because it's very easy. It's all about your intuition. Okay, right. So now this is single linked list. Of course, I don't need. Okay, I'll create a new class called linked list. Okay, I'll call it linked list queue, linked list base queue. So what we are going to do, we are going to keep two references, front, which is a node. Now, if you haven't done this, of course, you have wasted the opportunity, okay? Node, rear, okay? Now we need two operations. There's nothing called full or something, okay? Uh, that is enqueue, say void enqueue. So you need to send the data, right? So we use object, say data. Right. So now what we are supposed to do? So there's a special case that is if front. Remember we enqueue to the rear. If rear is initially both front and rear are null. Okay, front and rear are null. If rear is null, you make that your new rear. First of all, you need to create a node. Okay, say node equal, sorry, node n equal new node. So I told you this is not just learning data structures and algorithms. This is learning your, this is a playground for you to learn your object orientation. Okay, demonstrate your object oriented concepts. Right. So now I have created the node. Now what I need to do, I need to check whether rear is null. If rear is null, this is your rear, right? If rear is null, so your rear is n. That is special case. But in general, rear won't be null when you have data. Okay. Else, so your new rear will be rear, that we need to do two things. Now remember it's something like this now. So you need to do two things. Now we have already created the object, right? New object we have created, n. And now we know that rear is not null. If rear is not rear is null, of course your rear will be this one. Okay. Uh, Not only the rear, actually, we need to make front also this one, right? Because this is your first one. Okay. Right. So then if not, your rear dot next will be n. Right. Rear dot next will be n. That is your next thing. It's always, you can do it visualize. So now we know that rear is not null. Therefore, no null point issues. Rear dot next equal n. So that means now we have created this link. Right. This link. Now we need to take rear to this point because this is my new rear. Okay. Therefore, I need to take rear here. Therefore, rear equal rear dot next. Okay. Rear equal rear dot next. So you can't memorize this and go to the exam, right? It doesn't work. It will make you a lot of under pressure. Rear dot next. Right. So that is how you implement. So now, yeah, now the issue is in this scenario, rear is null means it's empty, right? So then we better make front also this one, right? Not only rear, let's make front also this one. Okay. Of course, you can implement it slightly different manner. Right. Is it okay? If this is your first one, of course, your both rear and front is this one because this is the first node. Else, I added a new node and make that the new rear, but all rear node is linked to the new node. Okay. So that means I should be able to now NQ. So then what about DQ? Sorry. Yeah, DQ. So in DQ, obviously you don't need a parameter. So therefore we'll say void DQ. So what you're supposed to do? Whatever the value in front, you need to return that object. Or okay. So the NQ code. So if okay. So if your rear is null, we create anyway we need to create a new node when you NQ. Okay. If rear is null, that means it's empty. We make your both rear and front as your new node. That's it. But if rear is not null, we make our rears next as new node because this is our new node. Rears next as new node, and then take rear to this one. So rear is new node. Right? Rear is rear dot next, or you can even say rear equal new node. Both work. Either you can write it like this, or you can say your rear is a okay. If you want, I can write it like that also, like this. Because rear is rear dot next is also now new node because now your rear dot next is n. Okay. By the way, rear dot next is n. So therefore, if you want, I can even write something like this. Your rear is n. Okay. Both work. Same thing. Okay. So now this is your rear. Now we are into the front. Now this is your because we are doing DQ from the front. You return this value, right? You return this value, then make your front is front dot next, front dot next. Okay. So let's return object. First, we will check if front is null. Let's do the happy scenario. Front is not null. Front is not null. So then we can return this value later, this node. Okay. So then let's have a temporary object which we will return later. So TMP equal front because we know that front is not null dot data which we will return later. Okay. So return TMP because DQ means you need the value. Okay. Else if front is not null, you need to do one more thing. What is that? Your new front is front dot next because we are going to remove this, DQ this. Okay. So therefore your front is front dot next. Okay. So that is happy scenario where we have data in our queue, our queue. But this is unhappy scenario. That means your front is null. Of course, then it's an easy thing. You don't need to do anything. Maybe we can just uh, log an error. Q is Q underflow. Q underflow. Underflow means nothing to DQ, but you try to DQ. Okay. Q underflow error. That is a standard word we use. Right? Standard word we use. So nothing to do. Okay. So then, of course, you return temp. Now, can someone tell me why this is error? So that is your
Because else is not returning anything.
temp is not. How to fix this?
No, else part is not
Yeah,
returning
how to
anything.
fix this?
So you can say TMP is equal to null, or else in object TMP we can say it's equal to null, and we don't need else part.
Yeah. So then easier thing is just we'll make it null. Okay. So that is your first solution. So now you can see the no error, right? So the answer is correct. Okay. Right. So if your front is null, obviously we return null. Okay. So therefore we initialize it to null. Right. Is it okay now? So shall we check whether we can NQ and DQ? If there are errors, we will fix it. So we'll call it linked list queue test. Linked list test. Main method TSVM. Let's create a linked list queue object. New linked list queue. And let's enqueue 102 data. Queue dot enqueue. Let's say 10. I can enqueue anything, right? I can say hi, Nimal. That is why I make it object. So that is how you develop software, right? Generic software, right? Reusable software. So let's say 10, 20, 30, 40. Let's DQ something. So DQ return. So therefore I can take it to Q dot DQ. So what should I get? I should get 10. Okay. Second time I should get 20 because first in, first out. So I should get 10 here. If it is implemented properly without bugs, I should get 20 here. If everything goes well, okay. Right. So 10 and 20. Okay, 10 and 20. So let's enqueue something again. Say 50. Then I will DQ another one. I should get 30 now. Next time 40. And next time I should get 50 because I have NQ 50 also. And next time I should get underflow error in the log. Okay. Right. You can see I always get, when I DQ, I get it in the same sequence, 10, 20. Now, next time, there will be error in the log because I get null, right? So there should be null and error in the log because I log it in my method underflow error. Right? You can see Q underflow error and it is null because I got null. Still I can NQ, right? Still I can NQ. Now the queue is empty. Right? Now the queue is empty. So let's NQ 60. Now there's no size issue here. Then we will DQ, okay? Right, so now I will get 60, 70, and again null and error. Okay, null and error. Oh, why is that? Why I'm not getting 60 and 70? So that means there's issue, right? You can see after it's getting empty, there's an issue. What is the error? So when we freshly enqueue, it works. But after emptying, maybe we have not uh, this null scenario we have not handled properly. Okay, so okay, let's do a debug. Let me delete this because we don't need this anymore. So the issue is somewhere here. Okay, let's see what happens when we have nothing. Nothing is there. Underflow error, we got it. Okay. Hmm. When you enqueue, if rear is null. Okay, let's do a debug. This type. Okay. Debug. Because when you're doing a final year project, of course, you need to heavily do debugging because no one is coming to you and fixing your issues. Right. So now my queue should be empty. Oh, still my rear has a data. So that is the issue, right? You can see my rear has a data. How comes my rear has data? So just one data is there. That can't be the case, right? Because now I have DQ everything. Still my rear has a data. Can someone detect the error? Mhm. So why after dequeuing everything, right, still I have data? Okay, let me have somewhere here debug. Right. So now I'm here. Now nothing to DQ. Now my queue must be empty. Okay, queue must be empty. Let's see whether it's empty. No, still you can see my rear has a data. My rear is referring to data. That is the issue. So we DQ from rear, right?
Yeah.
Yes.
If front and rear are same, so we need to say rear is equal to rear dot next also. If front and rear are same,
So
that's
that
the
means
problem.
we DQ with operation.
Yeah,
No, no. If front is null, that means else part, right? If
yes,
front is null, that means still my rear is referring to a node, right? Yeah. So I think yes, that is the case. So when I have one node, my front is also here, rear is also here. So then next time my front will be null, right? After returning this, my front is null, but still my rear is referring to this. Okay, so that yeah, that is the issue, right? So we get into a situation when we keep dequeuing. There's a situation where my front and rear both are the same. So then when I dequeue, right? After dequeuing, my front will become null because this one's next is null. Okay. So therefore, next time it will identify that it is empty. But still my rear is referring to this. Still my rear is referring to this. So therefore, when I uh, enqueue something, it will be enqueued to this point, right? This point. So therefore, the moment your front dot next is null, empty, your rear must also be empty, right? So that should be the case. So where should I rewrite this logic? If your front dot next is null, because sorry, yeah, then your rear must also be null, right? But where should I write this logic? That is my issue. After DQ, if front dot next is null, okay, if front dot next is null, that means rear must also be null, right? So we make it remove this, take the front to the next one. Maybe this now new front is null. If new front is null, the rear must also be null. Okay, let's write like this. If new front is equal to null, your rear must also be null. If there's no front, there can't be rear. Okay, I think now it should be okay, right? Okay, now let's run it and see. Yeah, now it's okay, right? 10, 20. So that is I'm dequeuing 10, 20, 30, 40, 50. Then I get null error. By the time, then I have enqueued 60 and 70. So therefore, next time when I dequeue, I get 60, then 70. Then again, I get null and error. Okay, null and error. Right. So now it's working. Right. So that is the case. Remember the last when what was the bug? When I am having only one element, right? When I am having only one element, then my both front and rear is here. So then I took it, right? And said front dot next is front equal front dot next. For front dot next is null. So therefore my front is now null. But still my rear is referring to this. But actually I have removed this. I have removed this. Right? So therefore, if front is null, that means I need to make my rear also null because this is already taken. So then you will ask, why don't we want to do this for other scenarios? Other scenarios, front and rear are in two different places. This is a special case where your front and rear is in the same place. So therefore, you can't just make your front null. You need to make your rear null also. Okay. Right. So that was a bug. Okay, that was a bug, and yes, your solution is correct, and that is what I implemented. I I missed that special scenario, but now the special scenario is also handled. Okay, so maybe you can, these are the type of places where you need to write a comment. So this is basically handling when last element is DQ, right? DQ. When the last element is DQ, this is a very special scenario where your both front and rear was referring to the only element. So therefore, you need to make your rear also null. Otherwise, your rear has no idea that this element is removed. Okay, DQ. Right. So that's it. Okay. So any questions? Let me copy this code. Right. So this is your normal array-based queue, and this is linked list-based queue. Okay. So for linked list-based queue, we needed the node class. I just copied it from the linked list. Okay. Right. So any question? I have not added that to your note because I have given it as exercise, but now you have the code. Okay. So the code I have given only for array-based circular linked list. Okay. You can see that actually this implementation is easier if you know your object-oriented concepts because there's no wraparound and so on. And this is there's no overflow also. As long as you have the memory, you can enqueue, you can enqueue. Okay, right, right. So now we move on to our next topic. If you don't have any questions, that is recursion. Right, recursion definitely we can finish it today also because that is not a data structure. Remember, we are in the data structure part. So far, we have discussed linked list data structure. The array is, of course, the basic structure. A stack data structure, queue data structure. We implemented stack and queue using arrays and linked list. Okay. So this is a programming technique. So then we have two more data structures, trees and graphs. Okay. Right. Recursion is a technique that you have already learned in semester one. Let me open the note. Right. So this is a programming technique. Right. So what is mean by recursion? A method calling itself. If a method call itself, we call it recursion. Okay. So if you just call a method, just call itself, it's a never ending recursion. It's useless. Okay. So therefore you need to call it, let me delete this. You need to call it conditionally. Okay. So let's have a class. So never ending recursion. Of course, this is useless. Say I have a method. I will use static methods. Say static void foo, and it calls itself. Say sout in foo, and then you call yourself. Okay, so let's have the main method psvm, and you call the foo method. Right? So now you should be familiar with these things, right? Why I make it static? Can someone tell me why I make it static? This method?
You can call it by class name straightly.
Yeah, just to make my life easy, right? Otherwise, I need to create objects and so on, right? Correct. So just to make it simple, okay? So you must have answer, right? Reasoning, logical reasoning for whatever you are doing. So that is what engineers, right? We are scientific minded, logical, right? You can see after sometimes my JVM has detected that okay, this is not going to be finished. It's going to kill all the memory. So therefore, it has stop it, finish it, okay, abruptly. Of course, this is not useful, but we can use recursion for our advantage as a problem solving technique because there are some problems in the world which are recursive in nature. Plenty of problems. Okay, so we will be using recursion in tree data structure, uh, graph data structure. That is why we are doing these recursion before moving to those two data structures. And we will be heavily using recursion in sorting, okay, searching, uh, because it's very useful uh, problem solving technique. So the idea is there are some problems which are recursive in nature, or the solution is recursive in nature. So in that case, when you have the big problem, you basically solve the smaller problem. So then you smaller problem, smaller problem, smaller problem. So when you have solved all your small problems, your big problem is solved. So that is the idea. Or in other words, you can think of it like you break your big problem into a smaller problem and further smaller problems. And when you have solved these small problems, you have solved your big problem. Okay, so that is the idea. Not every problem can be solved using recursion, but there are plenty of problems you can solve using recursion, or recursive solutions are there. Okay, right. And of course, we can use recursion in different ways. So that is why we have different types of recursion, like tail recursion, non-tail recursion, okay, and so on. So that is what we are going to discuss in this topic. Right. So if you are going to use recursion, uh, of course, your method must call itself. And when it calls itself, it does so to solve a smaller problem. And of course, you need to call yourself conditionally so that after some times, right, you must get out of the recursor. That means you have solved the problem. Otherwise, it will be never ending recursion. Okay. So that is the idea. So you just need to keep this in mind whenever you try to solve a problem using recursion. Right. So we can identify different types of recursion in programming. Tail recursion versus non-tail recursion, indirect recursion, nested recursion, excessive recursion. Of course, all of these are recursion, but it's the other thing is when you use recursion, you need to be careful because recursion needs a lot of resources, especially memory. Right? Say you call your method 100 times recursively. So until now, after you keep calling, there's a return trip. Until you return, if there are local variables in the method, right, local variables in the method, so that should be in the memory, stacked memory of the computer. Okay, so therefore, when you keep calling, then only you keep returning. So if there's a million times you are calling it, there are say one local variable in each method, so there are million local variables in your memory. Okay, so therefore we need to be careful when we use recursion. Now we need to think about how many times we are going to call it in practical situations and also try to limit the number of local variables. Okay, always you need to have this idea. You keep calling like this, and then only you are having the return trip. And at the end, you must come to the original call. That is where your final result is. Okay, right. So what is mean by tail recursion? So tail recursion means your recursive call is your last line, right? And your recursive call is at the very end of your method, recursive method, right? If it is not the case, that means after you call yourself, there are another set of instructions to be executed. Then it is non-tail recursion, non-tail recursion. So then what is the difference in implementation wise? There's a difference, that is, if it is tail recursion, right? If it is tail recursion, uh, in the return trip, of course, it has to come. through the return trip, but in the return trip, there's no processing step because nothing else to process. But if it is non-tail recursion, in the return trip, there is something to process because after the recursive call, there are statements. Now you need to execute this and then return this method to the previous one. Then again, there are statements, right? And so on. So if it is recursive tail recursion, in the return trip, nothing to process. If it is non-tail recursion, in the return trip also, there are each step you need to do some processing, at least one statement to process. Okay, there is a difference. There are situations tail recursion is enough, sufficient, but there are situations you need to go for non-tail recursion. Okay. Right. So this is an example for uh, tail recursion. Let me copy this code. Okay, let's write this code. That is better, right? Let's call this print numbers. So you give me a number, I will print from that number backward till 1. That is the idea behind this code. Okay. Say you send me 5, I will print 5 to 1. You send me million, I will print million to 1. Okay. Of course, this is not a big thing. We can even use a for loop. Okay. But we are going to use uh, recursion, a tail recursion. Okay. Say void uh, print. Let's make it static. This is my main method, PSVM. I'll call the print method. Let's say with 10. Right. Say int x. Right. So what I am going to do is I will check whether my value is greater than or equal to 0. If so, I will print it and call myself with one less value. Okay. If my x is greater than or equal to 0, I will print. This print is a S out print, okay? X. If it is 10, of course, I print 10. Right? So then I will call myself, right? That is my print method. But this time I'm going to send one less value. Okay, minus x. Okay. Now what happens if now first time it is 10, then 10 is print, then I call it with 9, 9 is print, then I call it with 8, 8 is print, 7, 6, 5, 4, 3, 2, 1 is print, then 1 minus 1 is 0. When I call myself, now it is not greater than, let's say only greater than 0. Now it is not greater than or equal to 0 because it is 0, therefore nothing to do. So therefore, that's the end of the story. So therefore, now it start returning. Now it start returning. Okay. Uh, because this is your last line. This is your last line. Else I am not going to do anything. Right? Else I am not going to do anything. Okay. So that means it's naturally return. So therefore, it will call, okay, let's make it 5. so that it call it 5 times only. So you first call your print method with 5, next call with print method with 4, call with print method with 3, call print method with 2, call with 1, and next time call with 0, but 0 doesn't do call again, it seems to return because 0 means nothing to do. It doesn't come to the if condition, so therefore it just return. Your method is all executed. So therefore this will not call again, it will return, and this will return because in the return statement, remember this is what with your previous call after calling, when this is returned, nothing else to do. So therefore you also return. Right? You also return, you also return, you also return. So that is tail recursion because in the return trip, nothing to do because this is your last line. Right? So that is what we call tail recursion. Okay, tail recursion. So you need to understand. So initially understanding recursion is a little bit right headache because you need to think recursively. Right? Your mind doesn't like think recursively because it's giving you some headaches at the beginning, but after some time you will be comfortable. Okay. So let's run and see. Right. So it print 5 to 1 and stop. Okay. That was the purpose. Okay. Right. Any questions? Yes, if you want to use negative number, you test it, check it. Okay. So that is up to you. That is up to you. Check whether it's working for negative number, or if you want to work it with negative number, what kind of changes you need to do. Right. So my task is just give you the technique. Your task is solving problems. Right. Your task is solving problems. So this is not like learning what is the highest mountain in Sri Lanka. So then your start stops when you remember it. But this is software development. Your start begins knowing the technique. So then you start solving problems. විදුරු තලාගල උසම කන්ද කියන එකෙන් ඔයාලට problem solve කරන්න බෑ නේද? හැබැයි recursion ඉගෙන ගත්තට පස්සේ problem solve කරන්න. Data structures ඉගෙන ගත්තට පස්සේ problem solve කරන්න පුළුවන්. Programming ඉගෙන ගත්තට පස්සේ problem solve කරන්න පුළුවන්. Okay? Right. So that is called tail recursion. Tail recursion. Okay. But if you have something like this, after this line, there's something. Okay, something. I will say hi. Now this is not tail recursion. Because in the return trip, when you return here, you have to do something in the return trip. Every return trip, there's something to do. Okay. So therefore, after printing 5, 4, 3, 2, 1, there will be 5 highs after printing this because it happens in the return trip. So then the output will be 5, 4, 3, 2, 1, then high, 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 high. That happens in the return trip. Okay. So that is what you need to experiment with and see what is it. Right now you can see this is not tail because in the return trip there's something to do. So this is that is happening. Okay. And another thing I can do is if I want, I can even print X. Okay, print X because X is a local variable. Parameters are local variables. Now what will be the output? Anyone? Now what will be the output? Earlier 5, 4, 3, 2, 1. High, 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 high. Now what is the output? Anyone? No, you need to tell me what is the output. You can't just say number. So I need the exact output. Of course, this is a number. Remember, this is a local variable now, right? It's local variable. Parameters are just like local variables. So local variables preserved. Okay. So the it will return print in the reverse order, right? You can see. So this is your last call. Okay. Actually, the last call is when it is 0. Now you are in the return trip. Okay. Now you are in the return trip. That is why it's 1, 2, 3, 4, 5. Let me draw it again because this is a very important technique. Okay. Say this is your first call. You call it with 5. So then you call it with 4. Then you call it with 3. Then you call it with 2. Then you call it with 1. Then you call it with 0 also. Now it's returning because x is greater than 0 only we are doing. So remember you get 5, 4, 3, 2, 1, then 0, right? Uh, 5, 4, 3, 2, 1. Actually 5, 4, 3, 2, 1, right? So then you are returning, right? So 0 is not now when you say, call yourself with 0, it's not doing anything because it doesn't get into the if condition. It just return. Now the output is 5, 4, 3, 2, 1. Okay. 5, 4, 3, 2, 1. 1 is print. Now you call yourself with 0, but it doesn't go into the if condition. So therefore it simply return, doing nothing. Okay. Now you are back here, right? But here earlier it was 1. Sorry. Earlier it was 1, but remember you make it minus minus x. Therefore you got 1. Your x parameter was 1, but because of minus minus x, now it is 0. Now you print high and your x, which is 0. Right here, what you got is 2, but because of the minus minus x, when you call it, now your x is 1, and it is preserved. What you got is 2, but now 1 because of the minus minus. Now here, what you got is 3, but now what you have is 2. What you get is 4, but what you have is 3. What you get is 5, but what you have it is 4. So therefore, in the return trip, you again print x, but you print x, now your x is 1 less than what you got. So that is why it is 0, high 0, high 1, high 2, high 3, high 4. Okay, high 4. So as an engineer, you must be able to explain exactly what your program is doing. Okay, what your program is doing, because this is formal science, right? So every line of code you write, you must know, you must be able to explain, this is what I did, this is the logic I wrote. You can't say that කලාවට මේක හරි ගිහිල්ලා එහෙමනම් කරන්න බෑ. ඒ රැඩිකල් software develop කරන්න බෑ. හරි. එහෙම කරන්න පුළුවන් physics chemistry. හරි. physics chemistry. ඒකත් දැනගෙන කරන්න ඕන. හරි පොඩි ලක්කයකුත් එතන තියෙන්න ඕන. Okay. Right. So that is the difference between tail recursion versus non-tail recursion. So there are situations you need tail recursion. There are situations you don't need tail recursion. Sorry, what you need is non-tail recursion. Okay. Right. If it is tail recursion, that means your code is the last line. Definitely you can replace your recursive solution with a loop. Right. Definitely. Okay. But if it is non-tail recursion, sometimes you may not be able to replace it with a loop. Rather, you need to keep always you need to keep a use the recursive call. Okay. Right. So non-tail recursion means it's not your last statement. Okay. So that I already explained. So I have given you some examples like enter a string and you reverse it. So if you have A, B, C, D, you print it as D, C, B, A. For that kind of things, you can use non-tail recursion because you keep that in your local variables and you print it in the return trip. So when you print it in the return trip, obviously you have print it in the reverse manner. So you can see it's an interesting solution. Right? You use your non-tail recursion for your advantage. So that is what happens in our output also, right? So in the return trip, if you print it, right? In the return trip, if you print it, because you are printing in the other way, not 5 4 3 2 1. It is 1 2 3 4 5. Okay. So especially when you want to reverse things, we can use non-tail recursion. Or when you need that in the reverse order, print not only print, you need to process it in the reverse order. Okay. Right. So the next concept is indirect recursion. So indirect recursion means now direct recursion means method call itself, right? Foo method call itself, of course, conditional, otherwise it's never ending. But remember, in our code, our print method call the print method. So that is direct recursion. X call X, foo call foo. But there can be situations where your F call, say your X method call Y method, and maybe Y method again call X method. Of course, conditional, otherwise again never ending recursion. So it's not X call yourself, but at the end it's a recursion because X call Y, but Y call X. So X call Y, Y call Z, and Z call X. So then it's recursion. But this is indirect recursion because you are not directly calling yourself. Okay. So there can be problems that you need to solve like that. Maybe you have certain processing is done, then you get back to the starting point again, right? Certain steps are done, and again you start from the beginning for the next step. Right? So that is called indirect recursion. Okay, like file processing. So certain parts are done by different methods, but at the end again you need to start for the next one. Okay, and so that is called indirect recursion. So the next one is nested recursion. Right? Nested recursion. So nested recursion means when you call yourself, when a method call itself as a parameter, say your method has a parameter. To calculate the argument for the parameter, again you call yourself, which is very rare, right? But there are some mathematical sequences, series, you can define like that. Okay. Say in simple, it is something like this. So I have a method called foo. If foo method call foo method itself, that is not normal recursion. It's not nested. But let's assume my foo method has parameter. Okay. And this foo method returns a value. Okay. Now, in order to calculate this parameter, you need to again call yourself. Okay. You need to call yourself in order to calculate this parameter. So that is why you can see this is a parameter, but as part of the calculation of the parameter, again you call yourself. So then you call it nested recursion, right? Which is very rarely used. Mostly those are used in special sequences and so on. Okay. But again, conditional, there can be some other scenarios. Okay. Otherwise, there won't be way out condition. Otherwise, there will be a never ending recursion. Okay. So then we call
Sir,
it.
I can't understand nested recursion fully.
So nested recursion means in your parameter, you have parameter in your method. That parameter also you need to calculate. To calculate that parameter, again, you need to call yourself, your method itself. So then we call it nested recursion. So there can be parameter, right? For the method. But you need to calculate that parameter. In order to calculate that parameter, you need to call yourself. So then it's nested recursion. So this is an example. For example, you can see here the parameter is there, but to calculate the parameter, you need to call yourself. Okay. Actually, this is one of the mathematical series. Okay. Mathematical series or sequence, sorry, not series. For example, if you want to do this, you can do a dry run. This is if n equals 0. When n is greater than 0 and m equals 0, this is otherwise. So you can take something like n equal 1, right? And m equal 1. So then you get into this scenario. So then you need to calculate the second parameter. To calculate the second parameter, again, you need to use this. But this time your n is 1, m is 1 minus 1, 0. So therefore, now this satisfies this scenario. N greater than 0, m 0. Therefore, you use this approach to calculate your parameter, then you call yourself. So therefore, it won't ended up in never-ending recursion because you do something changes to your parameter also, so that you calculate that using some other scenario like else if scenario, so that it will never get into never-ending scenario recursion. Okay. So basically, if your parameter need to be calculated or argument must be calculated by recursive calling the method, it's basically nested recursion. Okay, nested recursion. Right. So the next one is excessive recursion. Right. So excessive recursion means you call it more than once. Say this is your function. You don't just in the recursion, you don't just call it once. You call it more than once. You can see. So then it's like a tree. To calculate, say when n equal, let's take an example. So this is when n equals 0 and 1. Say I want to calculate, this is called Fibonacci series. It's a series in maths actually. So say when n equal 5, what happens? Right. So then this is when n equals 0 and 1 only. That is f5 is 5. Sorry, f0 is 0. From here we know that f0 is 0 and f1 is 1. But all the other cases you need to use this. So now I need f5. So f5 is 5 minus 2 is 3. F3 plus F 5 minus 1 4. Now you need to calculate F3, right? Because it's a recursive call. So what is F3? F3 is, again you come to this point because not 0 1, 3 is not 0 1. 3 minus 2 1. So this is F3 minus 2 1 plus 3 minus 1 2 F2. And what about this? So we'll call that this. F4 is, it belong to this. 4 minus 2 is 2. F2 plus F3. Now F1, we know. F1 is 1. But F2, again, you need to call yourself because 2 is not 0 or 1. So therefore, this is 2 minus 2 is 0. Right? F0 plus F1. Right? And F0 is 0. F1 is 1 because now you are 0 and 1 is this scenario. 0 plus 1. 0 plus 1 means 1. So therefore this is 1. 1 plus 1 is 2. So therefore this is 2. But this side still we need to do. F2. To F2 means F0 plus F1. and F0 is 0. F1 is 1. So 0 plus 1 is 1. So therefore this is 1. Now you need to calculate F3. Right? So I don't have space here, therefore I write it here. F3 is F3 minus 2, 1 plus F2. And now I need F2. F2 is F0 plus F1. F0 is 0, F1 is 1. 0 plus 1 is 1. Therefore, this is 1. And of course, F1 is 1. Right? So therefore, 1 plus 1 is 2. So therefore, this is 2. Then 2 plus 1 is 3. Therefore, this is 3. Then 3 plus 2 is 5. So therefore, F5 is 5. Okay. 1, 2, 3, 4, 5. Sorry, should be, I think this is F0. 0, 1, 2, 3, 4, 5. F5 must be 5. Okay. F5 must be 5. Oh, yeah, this is F0. F0, F1, F because it defined for 0 also. So yes, we got 5. So similarly, if you have F6, you will get 8. Okay, you will get 8. Right. So this is called Fibonacci series. You don't need to remember this logic. Okay, so just example because you call yourself more than once. So therefore, then it is like a tree. Your recursion is not going like a linear thing. So earlier, your recursion is like a line, right? Go like this and you return like this. But now it's expanding like a tree. Your recursion goes like this, and again like this, again like this. Okay. So it's and again these things must come to the leaf and again return. Then some calculations and returns. Okay. And so on. So this is called obvious. Now you can see it's excessive recursion, right? Because it doesn't grow linearly. Right? Excessive recursion. And we use this approach in binary trees, right? We use excessive recursion in binary trees. Okay, right. So you can run this program and you should get this kind of output. Okay, so you can double check with your dry run as well. Because you can see you are calling yourself, this is your method, more than once. More than once. Okay. And these numbers are now sum up in the return statements. So therefore, this is not a tail recursion also. Okay, because the return values are sum up and return. Okay, so that is like a processing step, right? Right. So I have given you few more examples, right? Some more examples for recursion. Uh, some of these are tail recursion, some of these are non-tail recursion. Okay, some of these are uh, non-linear recursion and so on, right? But most of these are linear recursions, right? I think almost all of these are linear recursion because non-linear or the excessive recursion is very rarely used, and of course, nested recursion is very rarely used in very special cases only. Okay, so this is a recursive. Now you need to do this as exercise. You want to find x to the power n recursively. That means you have a function with two parameters x and n. You need to return x to the power n. If your x is 5, n is 3, you must return 5 to the power 3. That is 125. First, implement this using loops. Of course, you can implement this without recursion. Right? Of course, it's super easy. Right? Can you implement a non-recursive solution for this one quickly? So this is the method signature. Don't use recursion. Just return, implement without recursion, right? I will give you 2 minutes. I will give you 2 minutes because it's even within 1 minute you can implement it. Right, quickly do it. I'll call it class x2 power n. Okay, yeah, it's a x power n. So you need to implement this without recursion. Say return, let's say integer, forget about double. This is my method, cal or whatever. In x in n. Then we will make it static so that we can call it straight away. When I call this, I will put it into S out. Call cal, say 5 and 3. I should get 125. Say 2 and 10, I should get 1024. Just to test two scenarios. This is 2 to the power 10, 1024. Okay. Right. Has anyone implemented it? Make a Takaskar implement control. You can put it into the chat. Because if you can't solve problems, right, no point learning programming, right? Because this is not memorizing theory. This is building your skills, competencies. So then you can think of recursive solution. X to the power n. Anyone? Make sure you test it also. I don't want to do it without you doing it, right? That is the thing. And of course, the finding factorial we have done in semester one also, that you can implement using first using without recursion, then with recursion. So every examples given here, you can implement without recursion also. Okay. So as I told you, when it comes to recursion, you need to think about the excessive memory usage, right? Of course, if it just go for 10 step, 12 step, that is fine. But if it is going for thousands of millions of recursive calls, you may ended up with a lot of memory usages. Okay, so just keep that in mind. First of all, try to minimize the recursive calls, so the levels of recursion or depth. Next, try to minimize the use of local variables. If it is absolutely necessary, use a local variable. Otherwise, don't use it. Okay, unnecessarily. So no one sent me the code yet. Right. So this is the non-recursive implementation. I want to get x to the power n. Okay. So anyone has written it? Okay. So I got one answer. I will just copy paste and see whether it's working. So I got one answer. I just copy paste from the chat. Okay. Not this. Where can't I copy the chat? It looks like it doesn't allow me to copy. Okay. Anyway, I write the code by looking at the chat. Okay. For I equals 0, I equals 0, I is less than, I mean your n, right? Yes, I hope you mean n less than n, I plus plus. Right, so this should be int I. So then result,
So I is equal to 0.
yeah, so
Use
the I equals 0. Then you result, but you are not returning it, right? So because you need to return value. So this method is not correct, right? Because you don't return anything. Because it says this result is, maybe you have not tested this. Okay. Base means I mean X. Okay. Uh, maybe you need this, right? Int R, let's say 1. Uh, maybe something like this, and return R. Is that your code? I don't know. This is not tested code anyway. Right. So now let's see whether this work. Uh, First of all, I don't think it should be 0, because then initially this is going to be 0, and all the time it's going to be 0, 0, 0, 0, 0, 0, 0. So therefore, first issue is this must start from 1, right? And 1 to n, that is 1 to less than or equal to n. Okay, less than or equal to n. Then it will go from first 1, 2, 3, 4, 5, 6, 7, and so on, right? Uh, So now you need to keep multiply yourself, right? So we can say x, not r, right? Yeah, we can say x multiply equal x. That is, if you get 10, 10 into 10, then that into 10, that into 10. How many times? N times. Okay. So then maybe we can return your x. Okay. So why can't we just return x rather than having this? Is it going to work? Let's do a dry run. If I get uh, 5 and 3, 5 and 3. Now my loop will go from 1 to 3. 1, 2, 3. Okay. 1, then 2, then 3, then you get out of the loop. For in the first iteration, my x is x into x. That is 5 equal. So x is x. Now my current value is 5. 5 into 5, which is 25. No, it can't be 5 into 5, right? So then this must be less than n, right? Yeah, so then this must be less than n, because first time also we get the second one, okay? Yeah, so this must be less than n. Then 5 into 5 is 25. So that is when I equal 1. When I equal 2, now, no, it can't be 25 into, then it will be 25 into 25, right? So no, it's not going to work. So we need to take it to R. Yeah, we need to take it to R, otherwise it's not going to work. And let's say this is R into X. Okay. Right. So now first time when I equal 1, when I equal 1, it will be uh, my X is 5, 5 into 1, which is 5. Right. When I equal 1, my R equal 5. Then I equal 2, my R is 5 into 5, which is 25. Okay. So then when I equal 3, it is 25 into 5 because I multiply by x. R is 125. So I need third iteration also. So that means this must be less than or equal to n. Right? Less than or equal to n. Is it going to work? It looks like now it's okay. When you get out of the for loop, you need to return your R. Right? So I think now it's working. Okay. It's working. Let's run and see. Yeah, 125,024. Okay. So now your task is do the same thing using recursion. Now this is not without recursion, right? This is without recursion. We use a for loop, right? But if you can't come up with this kind of a solution, also, I think the chat solution is almost there. I think this one is perfectly correct. Only thing is you have not written the and taken the local variable, okay? But this logic is perfectly correct. This is exactly the logic in your chat, okay? Right. So your task is now think of how to write this in a recursive manner. Okay, should I use tail recursion or not? Don't think about that. Just come up with a solution. Maybe it's a tail recursion, maybe it's non-tail. Okay, right. So that I keep it for you guys because the answer solution is there in your note. Right. So now we are done with recursion. Uh, so after the break, because we have not done object-oriented SAD for very long time, after the break we'll move on to object-oriented SAD. Okay, right. So now it is 9:30, say 9:35. We start at 9:55. Okay. I'll share you the code. Okay. Right now. Okay. So let's continue. So last time we discussed use case modeling. So use case modeling is used for understand the requirements or the functional requirements. Okay. So in agile terminology, user stories. Okay. So now we move on to another type of modeling. This is again related to requirement analysis mostly, activity diagrams. Okay, right. So let me open the note. Right. So we use activity diagrams to show or the model the flow of activities. Okay, so remember your requirements consist of use cases, right? So all your requirements, functional requirements, you can capture using use cases. So then why do we need activity diagram? Because use case diagram is high level diagram, right? Just say make payments, but make payment process may have more details, right? Individual activities. So part of that we can capture using use case descriptions. Okay, so remember we discussed about use case descriptions with precondition, post conditions, right? Use case ID, use case priority, the use case details and so on. But that is mostly textual description. But if you want to give it more detail, right? Flow of how a particular activity happens, we can go for activity diagram. It's another standard UML diagram, right? Another standard UML diagram. Uh, so this is an very high level example. So your activity diagram has start and end. So that is the start of the activity, end of the activity. Okay, big activity. So then you can have sub activities, or you can say this is a use case, and these are the activities. Okay, so your activities are represented using something like this, bit of elliptical shape here, and starting and end. And this is the flow. From this activity, it goes to these two activities. From this activity, conditionally, it goes to this activity or that activities. Likewise, there are something like parallel activities, uh, conditional activities, right? So there are a bit of concepts related to that so that we can proper uh, model the activities. Okay, right. So we have the activities, right? We have the activities. You have the transition between activities. Those are represented in these arrow-headed lines. Uh, so then decision points are there, something like this. Merge points, when you have a decision points, then there will be a merge points getting into a common activity. Synchronization bars are there. Okay, joins and forks. And optionally, you can have swim lanes, which we will discuss separately. That is optional. Okay, so this diagram doesn't have swim lanes. Okay, right. So activities are represented by uh, rounded rectangular shape. And you need to give very brief description about what is that activity. Actually, activity means sub-activity. And transition is represented like this. And this is how your starting of a business flow, end of a business flow. Okay, end of a business flow. So typically you must have one starting point, one ending point. Very rarely you can have multiple ending point, but this is for one activity. So therefore, most of the time, one starting point, one ending point. Okay. So if there's a conditional things, like for example, say if the order type is payment type is check payment, follow these activities. If it is card payment, do these things. So then you have a decision point, right? Decision point where you break it into different parts. So it will go either this way or that way, depending on that real world scenario. Okay, so decision point. So when you have decision point, so then there must be a merging point. Okay, uh, so that you again get into the common activities. Okay, so then you can have synchronization bars and forks. So that is where you start parallel activities. So that means after this activity, these two activities can happen parallelly. Okay. So that is called synchronization bar and forks. So when you have parallel activities, at the end of that, maybe again you are getting into one activity after both these two or three parallel activities are done. So then we call it a join. So you can see this is something like this is fork, right? One flow. Now we have multiple flows, but this is not a decision point. These are parallel activities. But at the end, after doing these activities, so then you have again join, and then you have common activities. Okay, so this is a fork. This is a join. Okay, this is a join. Right. So this is an example uh, for a typical order processing system. So this is your start. This is your end. So receive order. So then parallelly, these activities, this path and this path happen parallelly. Fill order. If it is a rush order, overnight delivery, else regular delivery. And this is your join. And while these are happening, this happens parallelly. So send the invoice and receive payment. So that according to this, it happens parallelly. And then you close the order when both these things are done. So it's very important when this path is finished and this path is finished. When both are finished only, it goes to the next task. Just because this is done, you can't go to the next. No, you need to wait until all the parallel activities are done to get into the next activity. Okay, right. So this is more requirement related activity diagram. Okay, but sometimes you can draw activity diagrams for designing as well. Okay, solution related things. So this is requirement related. So this is a little bit more technical, design related activity diagram, right? So validate the request parameters. Then parallelly, you call this particular web service and this particular web service parallel. And of course, there can be some error handling for particular web service. Okay. And when both these web services return error or whatever, when both we have the returns, then we go into the consolidate the results and show it to the customer or whatever another activity happens. Okay. And that is the end of the activity. Okay. So this is a very small topic. Uh, so that is how the activity diagrams are. So parallel activities can be there. Uh, Additions can be there. Okay. Uh, so then optionally, we can use swim lanes. It's optional. And it's optional. We can use swim lanes in our activity diagram. Okay. Right. So this is an activity diagram. You can see it looks a little bit odd because it has taken different activities to different lanes. Like swimming pool, when there's a competition, we have swim lanes. Right? So maybe this is what these activities are done by salesperson. Activities done by consultants are in this lane. Activities done by corporate technician is in this lane. So therefore, though it has been little bit distorted, uh, we can clearly see who is responsible for the activities. These lanes activities are for consultant. These activities are done by corporate technicians and so on. And other than that, of course, it's normal activity diagram. You can have decision points, merge points, parallel processing, and so on. Okay, right. So this is another example with swim lanes. This is when you take money from ATM machine. So this is these activities customer must do. These activities happen in your ATM machine, and these activities happens in the bank or the server, bank server. Okay. So for example, insert PIN, card, enter PIN, that is done by customer. Then authorization happens in the server. Okay. Uh, and so on. Okay. So then show balance, eject card. So those are done by your machine. Okay. Actually, the insert card must also, there should be a connection to the ATM machine that is not missing here. Because if your eject card is in the ATM machine, your insert card must also be done to the ATM machine, right? So there's a small issue here because I just took it from some book. Okay. Right. So anyway, it's optional, right? Swim lanes are optional. Just to just to show that where it happens or who do it or something like that. Okay. So this is another example. This is more of conceptual manner. Presentation layer activities, business logic layer activities, persistence layer activities. So this is more design related activity diagram, right? Right. So then some few new concepts in UML2. Remember, UML2 is now very old, right? But anyway, still you're not referred to it as new concepts in UML2. Anyway, UML2 is also now about more than 10 years old. But anyway, so in UML2, they introduce few more features to the activity diagrams. Okay. So one concept is you can show time passing, right? Passing of time. So there are some situations where this particular activity happens, then it wait for say 30 seconds, and then automatically the next activity happens. So then you can show it like this hourglass, say 30 seconds. That means after this activity happens, in 30 seconds, this activity automatically happens. Like open the door, wait for 10 seconds, close the door. Okay. So then this is another one. End of the business year occurs. send company tax return. Okay, so that is time related activity. So this activity is initiated depends on the time. This is again depends on the time. Okay, so those are new concepts introduced in UML2. Then they introduce another concept called exceptional activity. Remember, in a business flow, there can be happy scenarios, exceptional scenarios. Okay, so in case of exceptional scenario, so rather than showing it as a normal flow, if you want, you can just show it like this, right? Like this, okay? Like lightning. So that means it's an exceptional situation, like canceling order or error happens, login the error messages. So those are optional, very rarely people use, but those are the new, relatively new concepts in UML2. Okay. And also they introduce another concept, sub-activity indicator. So now you can divide your activity into sub-activities. If your activity need more details, rather than you make your big context activity diagram complicated, you can just have this kind of a fork symbol because these are usually drawn using tools. So when someone click on this, it open another activity diagram. So that activity diagram shows whatever happens inside this because this activity itself is a complicated activity. So then rather than you show the details here, because then your big picture activity become too detailed, you just show it as a uh, fork or something. For this, it's basically a link into another activity diagram, sub activity diagram. So then that you need to refer to that activity diagram to understand what happens here. Okay, right. So next new thing they introduce is they introduce something called input output nodes. If there's an input to output, that means some user interactions in that activity. Because in this activity diagram, you can't see exactly where the user interactions are. Okay. But when you look at the description, you can see, for example, enter amount, of course, there should be a user interaction. Okay. And of course, if you have swim lanes, that also show that, okay, this particular user must do it. But if you don't have swim lanes, if there's a user interactions, if you want to highlight that this activity is not pure processing step in the, rather it's needs some user interactions, you can show it in something like this. So if you have this kind of a, in your activity, right? In your activity, if you have this kind of a symbol, so that means in this activity, yes, there are user interactions. Okay. And the next new concept they introduce is flow final nodes. So remember, activity diagram has a start and end. Start and end. So usually you must have only one end. Right? But there can be situations the business flow ends in multiple ways. Maybe happy scenario, you come finish your order. But maybe in the middle, some customer can decide to cancel the order. So then finishing your order as a success and canceling the order is two different things. So then, rather than you have two endpoints, right? Two endpoints, you can just mark this activity as a flow final node. So that means you don't show multiple endpoints. Rather, your major flow, happy scenario, you have the end. But other scenarios, exceptional scenarios, and so on, maybe you can just say this is the final step. Okay, flow final node. Okay, but don't use it for the main flow. You may use it for the subflows or exceptional scenarios and so on. Anyway, these are all optional features. Okay, right. That's it. That's it. So that's it about activity diagram. Now you need to go through the university note as well. Okay, for the activity diagrams and finish it and do some part MCQs. Okay. Right. So it's pretty much the things I have already explained. Okay. Swim lanes and so on. Okay. Right. So our next subtopic, I told you that's why it took a lot of time to explain you what is object-oriented concept, polymorphism, because that is the important thing, right? Any fool can draw these diagrams, right? Who, right? But I always telling you, any fool can draw these diagrams, activity diagrams, use case diagrams, but only talented uh, people with attitude, logical thinking can develop the software, right? Write a logic, develop your software. Because in final year, everyone is drawing class diagrams, ER diagrams, blah, blah, blah. But very few students develop the software, unfortunately. So either attitude issue or they have no experience in coding, or they don't know how to handle complexity. But most of the time it is attitude issue. So they think that software or IT is reading notes, memorizing, vomiting in the exams. No, it's not the case. So IT is all about doing these things in practical manner. It's all about your attitude. Do you want to solve problems? Right? Do you want to solve problems? Build systems. If you don't have that attitude, what is the use of doing IT degree? Okay. I don't know. Right. So our next subtopic is classes or class diagrams and package diagrams. So this one we have pretty much done already because we did a good revision. Anyway, we'll do it. Okay. Right. So we can finish that one also. You can see we are going very fast. Okay. Uh, Structural modeling using class diagrams and package diagrams. For that, I have given you our own note as well. Then, of course, we'll go through the UCSC note as well. Okay. But first, we will be using our note. And this is a little bit bigger topic. Okay. So if someone asks what is the most important diagram in UML, so there's no doubt it is class diagram. Okay. So all these diagrams, sometimes actually we very rarely we draw activity diagrams, state diagrams, right? Yes, these are in theory, but the most important is for the requirement analysis use case diagram. Designing it is driven by class diagram. Okay, and database side of course the ER diagram. So in your final year project also, sort of a must-have diagrams are use case diagrams, class diagrams, ER diagrams. Other diagrams you need few, but this is what your project is all about, okay? Especially class diagram. A lot of students, they can't draw or model the class diagram because that means if you can't model your class diagram, that means, of course, if you are developing it using object-oriented way, so that means you don't know what you are doing. So that is where you need to do a lot of experience doing some sample scenarios, draw your class diagram, show it to someone, uh, and get some feedback. So if you send me a scenario and class diagram for that, I can give you the feedback. You just put it into the WhatsApp. Your scenario, your class diagram, maybe screenshot. Definitely, I will, right, uh, respond to you. Okay, but very rarely students do like that. Okay. So they keep waiting for the final year, and final year they don't know how to draw the class diagram, how to start development. Right. So we will look at what is a class diagram is, what are the elements of a class diagram, some best practices, and bit of design, mapping design to code. Because if you can't map your class diagram to code, then it's again no point, right? So it's useless because customers don't need set of diagrams. Customers need the software. Right? Right. So class diagram is a structural diagram. Remember the activity diagram is a dynamic diagram. Right? It's dynamic nature, but this is more structure. Right? The structure of your software. Okay. And it gives you the overall structure, big picture. Okay. Then this is the most important diagram or model in UML or in your design. So what kind of things are in your class diagram? Of course, you have classes and interfaces. Like classes, interfaces. Now, don't tell me that you don't know the difference between class and interface, because we discussed that in semester one in great detail, and I did a revision in the very first session. Uh, Obviously, it has classes and interfaces, and also inside your classes and interfaces, you can have attributes and behaviors. So then relationship between the classes and interfaces, or interfaces and interfaces. You can see class to class in relationships, interface to interface relationships, or class to interface relationship. Okay. Right. So you know what is a class is. I'm not going to discuss those things. So class is your blueprint, or it represent a set of similar objects. Okay. To represent all the payments, you have the payment class. To represent all the orders, you have the order class. To represent all the customers, you have customer class, and so on. And inside your class, you model your attributes and behaviors. So your attributes will end up as instance variables or class variables. Behaviors will be ended up as methods or class methods. And you know how to differentiate instance variable and class variable, instance method and class method. But in in class diagram, you don't differentiate. You don't differentiate whether it's going to be instance variable or class variable. It's just attribute. You don't differentiate whether it's going to end up as instance method or class method, because still we are in the design stage. Okay. So it's just attributes and behaviors. And of course, your class name. So these are some examples. Okay. So we have discussed these things in semester one. Okay. And when it comes to class, make sure uh, it's a noun, like order, payment, customer, right? Savings account. At the same time, be specific also. Okay. And it must be singular. Don't say customers, just customer. Okay. So then when it comes to attributes, again, it must be noun, right? Something like balance, account number. Okay. Again, it must be noun. Okay. And make it very specific and short. And when it comes to attributes, you can show the visibility. We have discussed this in semester one, private, uh, default or package, protected, then public. So I'm not going to explain those things because you have learned this in semester one. But I will just show you the symbols. If your attribute is public, use something like this, say account number. If it is protected, and your attribute name. If it is package level, something like this, an attribute name. If it is private, minus mark and attribute name. Okay. Public, protected, package or default, private. And this is same notation we use for behaviors as well. Because your behavior can be public, protected, package or default, or private. So when you use a tool, the tool have those. Okay, the tool has all these things. So remember, behaviors are the actions or services that particular class or the object of that class can provide. Of course, if it is static, the class provide. Instance method, it's the object can provide. Okay. But again, we don't show whether it's instance behavior or class behavior in class diagram. That is implementation condition. Right? And you need to give the behavior name, like make payment, parameters, return type, if not returning anything void, and of course, visibility. Okay. Public, protected, package, and private, same symbols. Right? So this is a full version showing both attributes and behaviors. So we have make account number and account type private, interest rate protected, and balance package level. Okay. These methods are public. Okay. And this is protected. Okay. So when it comes to implementation, as I told you, attributes may end up as instance variables or static variables. Your behaviors will end up as instance methods or class methods. Okay. Right. So interfaces will take separately. Let's first look at what are the relationship between classes. Right? What are the type of relationships between classes? So we have already discussed association and inheritance, right, from semester one and during our revision also. Okay. Uh, so let's take one by one again because this is we are formally doing class diagrams. So the most widely used relationship is association. If you take class diagram, a practical class diagram, sometimes almost 90% of the relationships are associations. And unfortunately, this is the one that is most of the students have no idea. Because a lot of students, their only relationship they know is inheritance. Inheritance. But inheritance is not the most widely used one, it is association, right? That is why we took some time and discussed that at the beginning of our revision as well. So, so what is mean by a class A associated with class B? So class A associated with class B means what? Object of class A can call behaviors of object of class B. Simple as that. Okay. Or we call it message. So if there's no association, you can't do that. And it can be unidirectional or bidirectional. So this is unidirectional. A is associated with B, but B is not associated with A. That means A can call behaviors of B objects. B objects cannot call behaviors of A objects. Similarly, it can be B to A or bidirectional means no arrow. No arrow means A is associated with B, B is associated with A. That means object of A can call behaviors of object of B. Object of B can call behaviors of object of A. Okay. Or for the behaviors which are allowed. If it is a private behavior, of course, you can't call it even though you have association. So an object calling a behavior of another object is called messaging. So this association means you can message. If there's an association between A to B, that means you can message or call behaviors of that class objects. Right, so we discussed this at the very beginning in our first day, and also we have discussed this in our semester one. Okay, right. So here we are more interested in how to model it. Okay, so when it comes to association relationship, so these are the important aspects: navigability or direction, can be unidirectional or bidirectional. Multiplicity, it can be one to one, one to many, or many to many. When I say one to one, it can be again one to zero or one. When I say one to many, again it can be one to zero or many. So that is called whether it's optional or not. So then, of course, your relationship, you can give it a name, association, a name, and optionally you can have role names. Role names. So usually you have either role names or association name, not both. Okay. Right. Association name must be uh, meaningful so that someone who look at your class diagram can easily understand the association. Like loan settled by installment, vehicle driven by driver. Maybe EC is not required. Maybe vehicle driven by driver. So then someone will find it easy to understand your class diagram. Okay. So that means vehicle can has associated with a driver. Actually, this is not a very good way to present it. Actually, it should have been other way. Driver associated with vehicle rather than vehicle associated with driver. But if you are driven by vehicle side, maybe this is correct because you are more interested in vehicle than the driver. Maybe this direction is also correct. Okay? Or maybe this is bi-directional. So as I told you, you can optionally have role names. So the association name is somewhere in the middle. Role names are in the on either sides. Sometimes you can have role name on one side only. Sometimes you can have role names in both sides, but most of the time it's only one side. So that means you can see there's a connection, association between lecturer and student. But this is typically lecturers teach, right? Lecture students. But maybe this is a different story. So that is why we have gone for uh, role names because this is lecturer supervise student. So that means your lecturer is playing the role of a supervisor and student is playing the role of a candidate or something. But maybe this is optional, right? But this is definitely your lecturer is now playing the role of a supervisor. It's not you are doing lecturing. So in that kind of situation, better you add role name. Okay, role name. Both side or single side. But again, don't do those things for the sake of doing. If you feel like it add value, right? It helps someone to understand the class diagram, use it. Right. I already explained that your association can be unidirectional or bidirectional. Okay. So this means object of A can call behaviors of object of B, but not other way. Okay. Right. You can see object of A can call behaviors of object of B for message, but not the other way. Right. So we did this kind of examples. So therefore, I'm not going to do it again. So how do you know that? How do you implement this? So then your class A must have instance variable of class B. You can see class A has an instance variable of class B. This is your class A. It has instance variable of class B. So that all your behaviors, methods have access to this B object. Of course, you need to create the object before you set the object. Either you create the object here itself for constructor. So then whenever A object is created, B object is created internally. Or you set it. You set it. Right. So this one is use set in the object rather than create the object. Okay. So here you can see we have created A object, we have created B object, and we have set that B object to A. Right? So now this B object is associated with this A object, set B. Now your A object has the help of a B object. Okay? Otherwise, internally in your class A, you create the B object. Okay? So there are pros and cons. දැන් ඔයා බලන්න මොකද්ද මේ දෙකේ වෙනස? If you are really serious, if you really want to be a software engineer, එතනින් එහාට හිතන කට්ටිය software engineers ලා වෙයි. හිතන අය. හැමෝම වෙන්න ඕනේ නැහැ software engineers. It's a different story, right? software engineers ලා මේවා හිතනවා. Okay? software engineers ලා මේවා හිතනවා. Okay? Right. So this is how the message passing happens. By the way, next we are going to do sequence diagrams. Now you can see that object of a class A can call behaviors of object of class B because you have the object or you are given the object. So you can see behavior of A referring to calling behaviors of object B. Object B. So this is how the object-oriented systems are developed. Set of objects communicate and collaborate to achieve the functionalities of the system. Okay. So remember we discussed about that money transfer example. මේක තේරෙන්නේ නැත්නම් ආයෙ කල්පනා කරනවා. හරි. ඉතින් තේරුම් ගන්න ඕනද නැද්ද කියලා තීරණය කරන්න. right ඔයා කියයි නෑ මම තේරුම් ගන්න ඕනේ මට මේ සාති කැලල ගත්තම ඇති. Okay, that's fine. That is your decision. But sometimes you may feel like, no, I don't just need the BIT degree. I need to understand these things. Maybe I want to use my knowledge and do something, build something. Okay. So this is how the message passing happens. This is my test class where we have created a object. Now my test class can call behavior of A object. So when I call the behavior of A object, remember A object has association with B object. It can get the help of that B object. So when I call the do-way, inside do-way method, A object called do-B of the B object and get that results to return me the final result. Okay. So that is message passing. And message passing is possible because there's an association between A and B. Okay. Any questions? Any questions? So spend a lot of time with your chat GPT and your IDE. chat GPT එක කතා කරලා හරියන්නේ නැහැ. එයත් එක්ක කෝඩ් කරන ගමන් එයාගෙන් හිර වෙන දේවල් එයාගෙන් අහනවා. හිර වෙන දේවල් එයාගෙන් අහනවා. ඉස්සෙල්ලා ඔයා පොඩි කෝඩ් එකක් ලියන්න. නැත්නම් chat GPT කියන්නේ මට පොඩි එක්සර්සයිස් එකක් දෙන්න. හරි. ඊට පස්සේ ඔයා ඒක කරන්න. ඊට පස්සේ ඔයා ඒ කෝඩ් එක එයාට පේස් කරලා අහන්න මේක හරියද? මොකද්ද මේකේ අවුල? අන්න එහෙම ඉගෙන ගන්න 20යි 25යි. Okay? 20යි 25යි. ගල් යුගයේ නෙමෙයි පොඩි. Right? So go to ChatGPT. Give me a simple example. Exercise. Simple coding exercise to demonstrate association. I'll say practical exercise. Simple but practical. And don't worry about the spelling mistake. It can detect those. Right. අය කියන Python කියලා කියන්නේ මට Java එකක් දෙන්න කියලා ඕන. හරි? So exercise library and book association. We want to model a library that has collection of books. A book can exist without a library. The library just uses book objects. එයා අපරන් starting code එකක් ලියලා දීලා තිනවා. මම කියන්නේ මේක Java code එකක් කියන්න කියලා. Java exercise. Please කියන්න ඕනේ නැහැ chat GPT ලා හරි තමයි. Right, so perfect. Let's switch the same association example to Java. Their starting code එකක් ලියලා make a one to many because a library can have many books. So that means you need to keep a list of books. බලන්න එයා උදව් කරනවා. හරි වැඩක් කරන මිනිස්සෙට උදව්වක් ගන්න මේ පුළුවන් ඕන කෙනෙක්. ඉතින් වැඩක් නොකරන කාට තමයි ඔහේ ඉන්නේ කාලකන්නියම. හරි එයා කෝඩ් එක ලියලා දුන්නේ මම එයා හිතුවේ මම කෝඩ් එක ඉල්ලුවා කියලා හරි. So here you can see that the library class, so this is the book class. So book class is just a simple class because this association is unidirectional. Library associated with books but not book associated with library. Yeah, may I get to an instance variable library, but library will have list of books, so array of books. Maybe list of books and instance variable. Yeah. Association. Library has books. So the software develop when we develop right? Your shopping cart has items. Those items can be uh, product items. On shopping cart එක develop කරන add to cart method එකක් මේකයි. අනිත් කලින් එයා generate කරලා දුන්නේ Python code එකක් පොඩි Python code. Of course. Same thing, right? ඒක කරන විදිය මේක කරන විදිය චුට්ටක් වෙනස් ඉතින්. This is a book class and this library class. I think books list එකක් විදියට දාගන්න. මෙහෙම තමයි software develop කරන්නේ. මෙහෙම තමයි software develop කරන්න ටික ටික. ඔයාලට කියන්න මීට වැඩිය මට වෙන practical example එකක් දෙන්න. UI පැත්තේ. So UI related. එතකොට එයා සමහර form එකක් තියෙනවා form එක ඇතුලේ buttons ටිකක් තියෙනවා කියලා දෙයි. හරි. නැත්නම් form එක ඇතුලේ text boxes තියෙනවා. Say Java swing UI example. අය දැන් UI එකක් දාන්න හදන්නේ මේ book සහ මේ වලට library එකට හරි. So J frame එකක් දාලා දැන් මේක ලස්සනට කරන්න හදන්න. කියන්න තමයි වැඩේ කරන්න. අපි copy කරලා run කරලා බලමු. ඔක්කොම code එක ලියලා තියෙනවා lazy කරන්න හරි. So let's start IntelliJ. මොකද මේක තමයි වැදගත් හරි. නැත්නම් ඔහි ගොනා බూరు ආසේ කරලි වෙලා අන්තිමට ප්‍රැක්ටිකලි යමක් කරගන්න බැරි වෙනවා. ඊට පස්සේ finally project class. ඊට පස්සේ මොනවද job class. job class. ඊට පස්සේ මොනවද කසාද බඳින class. හැම එකම අනුන් කරනවා. Taman දන්නේ theory එක විතරයි. ඊට පස්සේ හැම එකම ආණ්ඩුවෙන් ඉල්ලනවා දියව කියලා. අයි Tamanට කරගන්න පුළුවන් දෙයක් නැහැ. පෙන්ෂන් ගිහිල්ලත් කෑ ගහනවා. මේ කොච්චර ලිවද දන්නේ නැහැ මම. රන් කරලා බලමු. Because I didn't go through the code. There are red codes, right? Red codes thing. There must be compilers. Why is that? File name එක library app වෙන්න ඕන. Because it's a public class. It's library app. Let's rename the file. Because your public class and file name must be the same. Cute scene earlier. Let me come inside title, say Java, say head first Java, right? Author, I'll call it O1, say Kevin. So now it is there. Okay. The add to cart together, so it's just the add operation is there. Okay, nothing else. The article make remove karanna, make a shopping cart එකක් කරගන්න. Maybe you can convert it to a later web application, JSP servlet. Okay. Make a remove functionality දාන්න පුළුවන්. Right? Something like that. Then you can save this. බිලක් නම් දැන් බිල save කරන්න පුළුවන් වාට. මේ බිලේ items add වෙන්නේ. So then you can think of, okay, this is not a library, this is my bill, like a supermarket system. Okay. So it's all about the imagination, your passion. Okay. Right. So that is unidirectional association, and it's one, I just use one to one. This is one to one, right? One to one unidirectional. So this is bidirectional association. Object of A can call behaviors of object of B. B can call behaviors of object of A. This is tricky scenario. So don't go for A has object of B, B has object of A, just the reference variable. You set it, because otherwise you will get compiled errors, because A try to create an object of B, B try to create object of A. It's a recursively they try to create objects. අන්තිමට ඉවරයක් නැතුව object හදන්න පටන්. Okay. So therefore, in this kind of situation, definitely you must go for setting. You can see for in A, we set B. Right? In B, we set A. So then you don't have any issue. You can see in B, you set A. You can see. Right? In B, you set, in A, you set B. In B, you set A. So rather than you create objects here, මෙතන object හදන එක එච්චර හොඳ නැහැ. So now A can call behaviors of B objects, because every A has a B, every B has a A. සහයට ඉන්නවා තව එක්කෙනෙක්. Okay. So here we have created A object and B object, and we set that B object to A object. Set B. So therefore now A can, when I call do A on A get the help of B objects. B object එකේ help එක ගන්නවා මේ do A1 method එකේදී. ඒක තමයි කලින් ලියුවේ do A1 method එකේදී. So during do A method, it get the help of the B object. So that is collaboration. Collaboration. So in object-oriented, one object is not doing everything. The object can get the help of other objects. So, okay. So every object has its own task. Every class. මේක හරියට තේරුම් ගන්නවා. ඊට පස්සේ ඔය වැඩේ කරගෙන යන්න. So this is because bidirectional now, from A can call behaviors of B objects. B objects can call behaviors of A object. Depend in different scenarios, right? Not in the same scenario. This is one scenario possibility. This is another possibility now. So this is also possible. Your V objects can get the help of A objects. But those are different methods. එක method එක කරන්න බෑ. Then it is recursion. ඒකත් තේරෙනව නේද? දැන් A object එක B object එකේ method එකක් call කරනවා. B object එක A object එකක් හදාගෙන ඒක පාර දෙන්නට දෙන්න recursively object හදා දෙන්න. So මේ practical දේවල් වෙලාව බලන්න ඕන. ඊට පස්සේ බලමු මොකක්ද යකෝ මේ උනේ. එතන මතක නෑ යකෝ මේ recursively. recursion නේ. මේ object level එකේ recursion එකක් කරනවා. So this can't happen. කියන්නේ Aට වැඩක් කරගන්න ඕන B ක උදව් ඕන. ඒ උදව්ව ගන්න ඕන වැඩේ කරගන්න ගියාම Bට ඒ ඕන වෙනවා අපව. අන්තිමට A Bට උදව් කරනවා B Aට උදව් කරන වැඩේ ඉවර වෙන්නේ නැහැ. Right. So the multiplicity, now you know that it can be unidirectional or bidirectional. So multiplicity can be one to one, one to many, many to many. Right. So remember that ChatGPT generated that example where library can have many books. It's one to many. Okay. One to many. But when it comes to modeling, we need to show whether it's optional or not. So therefore, it's one or zero or one. Many or zero or many. Many means zero is not possible. One no more. But this means zero or one no more. So this means one. So this means one no many, not zero. So this is these two are two different things. This is zero, one no many. This is one no many. It's mandatory. Or you can have exactly this number of objects. Right? For example, car object is associated with four tire objects. Okay, four. Or you can say it's 5 to 8, 3 to 2, sorry, 3 to 5, minimum 5, maximum 8. Okay. Right. So one to one we discussed already, therefore you can refer to the same code. One to many, this unidirectional one to many, this bidirectional one to many. But one A object is associated with many B objects. But one B object is associated with one A object. Say, your form can have many buttons, but one button is belonging to one form. Your shopping cart can have many items, but a shopping cart item belong to one shopping cart. Your bill can have many bill items. One bill item belong to one bill. So think practically. Your class can have many students, but one student belong to one class. So here we are using a array. One object of A associated with many object of B. But one object of B is associated, this unidirectional. B is not associated with A. This is unidirectional one to many. A associated with many B, but B is not associated with A. That means B cannot call behaviors of A, or the B object cannot call behaviors of A objects. But A object of A can call behaviors of object of B, not just one object. It can call behaviors of set of objects of B. So that is why here in a in your iteration, you can see we have set of B objects, array of B objects. For each and every object, we call the do B behavior. Do B behavior. මේ කවදා හරි තේරුම් ගන්න මේක තේරුම් ගන්න නැති තාක් කල් වල software engineer කෙනෙක් වෙන්න බෑ. software engineer කෙනෙක් වෙන්න බැරි. එතන ගිහිලා කෝඩ් එක ගත්ත ගමන් නැත්නම් ඔයාලට කලන් දාලා වැටෙනවා. ඊට කලින් ඉන්ටර්වියු එකේදී අහු වෙනවා. Okay? ඉන්ටර්වියු එකේදී අහු වෙනවා. So the YouTube එකේ ගොඩක් තියෙනවා මේ practical software engineers ලා කරන channels. හරි. පොඩ්ඩක් ඒවට ගිහිල්ලා බලන්න ඒගොල්ලෝ මොනවද කියන්නේ. හරි. Facebook එකේම ගොඩක් ඔය software development company ඇතුලේ කරන trainings තියෙනවා. ඒවයි දානවා ඒගොල්ලෝ recordings දානවා. හරි. හැබැයි මතක ඇතුව software field එකේ ඉන්න අයගේ ඒවා බලන්න. හරි. සමහර ඉන්නවා software field එකේ ජීවිතේ දවසක් වැඩ කරන්නේ software field එක ගැන කතන්දර කියනවා. හිතේ තියෙන දේවල්. So that doesn't work, okay? හරි තේරෙනවා මෙයා software engineer කෙනෙක්, මෙයා architect කෙනෙක්. හරි. මිනිහා විශේෂයෙන් මෙයා ඉන්නවා තාම field එකේ. අන්න ඒගොල්ලෝ කියනවා හරියට තමයි හරිම කතන්දර. Okay? හරිම කතන්දර. Right. If you go to YouTube and also make sure you are having a LinkedIn profile now. Right? LinkedIn profile එකට ගියාම ඒගොල්ලෝ articles ලියන කට්ටිය ඉන්නවා. Give yourself 28 days and become the most. There are so many people, right? I don't know exactly. I don't want to recommend, right? It's a day of a trainee, software engineer. IFS එකේ දවසක් එයාගේ කොහොමද උනේ කියලා දාන්න මම දැන් කලින් බලපු රෙකෝඩින්ස් නේ මම just I did a search, okay? So then you can get ඔය මෙහෙමයි කියලා සමහරව හැබැයි ඉන්නවා නිකන් ජීවිතේට කරපු නැති කට්ටිය බයිලා කියනවා. හරි. ඒව බලන්න එපා. ඇතුලේ ඉන්න කෙනෙක් කියන කතන්දරය අහන්න. හරි. ඇතුලේ ඉන්න කෙනෙක්. නැත්නම් අවුරුදු 5ක් වැඩ කරපු කෙනෙක්. So let's see what kind of things they talk. I don't know. I have not seen this video anymore earlier. So this is their just showing their life. Okay. So this is, I think, Orion City office. Okay. Yeah, this is Orion City office. මේ ඇවිල්ලා මේ කෝඩින් කරන්නේ වනේ මේ හැබැයි කියන්නේ ආ. So there are some about training sessions and so on as well, okay? So their experience and so on, okay? Then nothing coding නෙමෙයිනේ. So then only you can get a feeling of it, right? What is your real ඔය නිකන් වෙන විදිය කියලා කියන කතන්දර බලලා හරියන්නේ නැහැ බయ్యා. ඇතුලේ ඉන්න අය ඇතුලේ ඉඳලා කියන කතන්දර තමයි අහන්න ඕන. හරි ඇතුලේ ඉඳලා ඇතුලේ ඉන්න අය ඇතුලේ ඉඳලා කියන කතන්දර. ඒ කියන්නේ බලන්න මේක කම්පැනි එක ඇතුලේ ඉඳලා කතා කරන්න කියලා අඩු ගන්න. හරි කම්පැනි ඇතුලේ ඉන්න කෙනෙක් කියන එක තමයි අහන්න ඕන. මොකද පිටේ ඉඳන් බයිලා කියන කට්ටිය සෑහෙන්න ඉන්නවා. හරි. ජීවිතේට කම්පැනි එක ඇතුලට ගිහිල්ලා නැහැ, වැඩ කරලත් නැහැ. Right. So this is one to many unidirectional. So remember my A has association with many B. So therefore my A object can call behaviors of set of B objects. Set of B objects. Okay. So you can see my test class call behavior of A object. Now A object can send messages to set of B objects. Set of B objects. Okay. So next object and so on. එතන මෙන්න මේක එන්න ඕන දැනුයි. මේක ඇවිල්ලි ඕනනම් තමයි පොඩි මේක පොඩි අවුලක් තියෙනවා. So this return must be after doing this loop. Okay. So there's a small issue here. මෙන්න මෙයා එන්න ඕන අන්තිමට. അതിന് അന്തിമട്ട് ഞാൻ പോയിട്ട് കാണും. Right, so now it should be okay. So then only this can return, right? So this send a message to this guy, and A object can call behaviors of multiple B objects because A has array of B objects. Okay, right. So this one, they're going to loop again, yeah. Remember, our next set of diagrams are sequence diagrams. Okay, so this is sequence diagram. Now, after calling all these things, now you can return to your test class. Okay. So now think about a practical situation. Can someone give me a practical situation where this kind of a thing can happen in a software? Anyone? I don't mind whether it's correct, wrong, somewhat correct, perfectly correct. I don't mind. Anyone? But you need to tell me what are the classes, what are the methods. Right? I need just a specific example. Anyone? No one? Of course, there can be hundreds and thousands of scenarios, okay? But I need a very specific answer with what are your classes, what are the objects, and so on. Transaction processing system. I don't need the software's name. I need what is your class A, what is the method, what is your class B, what is the method you are calling. Something like that. I told you I need a specific answer. Say you want to get a report, right? You want to get a report from a bank. Say a particular customer has multiple accounts, right? So multiple accounts, particular customer. Now you want to get statement about this customer. Customer asks request because then September 30 වෙනිදා ටැක්ස් ෆයිල් කරන්න තියෙන දවසනේ software engineers ලා ඔක්කොම වගේ ටැක්ස් ගෙවන කට්ටිය. හරි? pay tax ගෙවන කට්ටිය ඉන්නේ. ඒතකොට ඒගොල්ලන්ට ටැක්ස් ෆයිල් කරන්න ඕනේ දැන්. කැපිලා ගියාට ඒගොල්ලෝ ගාව multiple accounts තියෙනවා නම් ඒගොල්ලෝ දැන් බැංකුවෙන් ඉල්ලනවා මට දෙන්න මගේ bank statements. But maybe you have multiple accounts. So then what they do? Take the first account and calculate your extract your transactions. Second account, extract your transaction. So you have three accounts, third account, extract your transaction, then put it into a report, and that report is written. But you need all your transactions from all your accounts, right? Because your customer has, say, multiple accounts, say one savings account and two fixed deposits in the same bank. So likewise, you need to think practically. Okay, you need to think practically. Maybe this is a transaction. So this is, remember, it's a money transfer between two accounts in the same bank. So then so this account, these are your transaction object. So then you call this object, it's debit. This object, credit. Right? Both are accounts. Account 1 debit kara, account 2 credit kara. So then you consolidated result, success or failure you return. And here you need to do transaction handling also, because if this done and this is failed, you need to roll back this. Right? So that is how software is developed. Okay. Right. So that is one to many association. Okay. One to many association. This is then what we class diagram එකේ කොහොමද එන්නේ? මෙහෙම. One to many. So this is one to many association. This bidirectional unidirectional. So then what happens in a sequence diagram? Right. So this sequence diagram. This is the big picture messaging. Right. So you need to have that big at the end your class diagram, sequence diagram. Right. So you need to have the big picture because it's one system. It's one system. Okay. Right. So remember, you can have reflexive association. Right. That means you associated with yourself, a class associated with itself. So then what happens? It can be again one to one, one to many to many. Okay. So then your class has instance variable of its own same class. Right. Instance variable of same class. Okay. So you can see this is my player class. Player class. And player class has the instance variable of another player. You can see this type data type is player. This is also player. Of course, we have given it a different name, partner. Say it's a chess game. So if player is playing with another player, right? Player is playing with another player. Right? So recursive. Okay. Like two people chatting. So chat is between two users. Right? So this guy also can message. Other player also can message because player class has message. So then A message to B, B message to A. Okay. Think about it. Practical scenarios. Right. So that's it about association. I did not explain much about many to many. Okay. Because you need little bit more experience, exposure to understand how the many to many relationship really work. And one of the techniques. Sorry. Don't worry too much about that for the time being. Right. So our next relationship is aggregation. Sometimes we call it has a relationship. Our next one is composition. So what we discuss is association, something like this or this. But you can see there's a diamond shape. So aggregation is a special type of association. Okay. Aggregation is a special type of association. So association means A can call behaviors of B or B can call behaviors of A or both, right? It's association. ඒ කියන්නේ යාළුකමක්, හිතවත්කමක්, මිත්‍රකමක්, සංගමයක්, ආශ්‍රයයක්, සහයෝගයෙන් වැඩ කිරීම. So then aggregation is a whole part relationship. ඒක ඊට වැඩි වෙනස්. So this is part of this. This is your whole, this is part. It's a stronger special association. Right? It's a stronger special association because it's not just just association. No. This is part of this. Part of කිව්ව ගමන් ඒක strong නේ නේද? ඒක strong. Okay. So therefore, in reality, Odd and odd item is actually something like a whole part. It's not association, ideally. Okay. But order and payment, customer and order, that is association because customer order is not part of the customer, right? Order can customer it's association. But engine is part of the car. Order item is part of the order. Order items are in the order. Okay. Actually, order item and order is actually not aggregation, it's a composition because composition is a special case of aggregation, right? But let's for the time being consider it as a whole part. Okay. And we show it like this. Okay. Again, it can be one to one or one to many, but this can't be many. Right? This side can't be many. This side can be one or many. Okay. Right. So the next one is composition. So composition is a special case of aggregation. Remember, aggregation is a special case of association. Composition is a special case of aggregation. Aggregation is a special case of association. Composition is a special case of aggregation. So therefore, composition is also whole part. But this time, part cannot exist without whole. Part has no independent existence without whole. So that means part is tightly bound and depending on the whole. So then we call it composition. And just to show that it is stronger one, you shade it. Shade it. Okay. Like a ward and hospital. Ward cannot exist without hospital. වාට කියනවා දෙකේ වාට්ටුව. ඒක මම අහන මොන ඉස්පිරිතාල නෑ ඉස්පිරිතාල නේ එක දෙකේ වාට්ටුව. එහෙම බෑනේ දෙකේ වාට්ටුව නම් මොන ඉස්පිරිතාල දෙකේ වාට්ටුව. කොළඹ නැෂනල් හොස්පිටල් එකේද? ජයවර්ධනපුර හොස්පිටල් එකේද? So that is not aggregation. So then it should be composition. But anyway, we don't care much about the difference between composition and aggregation these days. Because whether part can exist or not is not a big issue when it comes to designing. So therefore, in modern new UML, usually we just consider composition and aggregation as the same. But anyway, still when you learn it, you must know that composition is a special case of aggregation where part cannot exist without whole. And of course, aggregation is a special case of association. It's not just association, it's whole part. Okay. Strong association. Okay. Right. So the last relationship between class to class is dependency. This is the weakest association or weakest relationship, and most of the time we don't show it also unless it add value. Right? Add value. So that is the weakest relationship that we show in class diagrams. So what is meant by dependent? Dependence. Say for example, let's say this is a son. This is the father. So there's association, right? පවුලේ අතර හොඳ සම්බන්ධයක් තියෙනවා නේද? කතා බහ කරනවා. ගෙදර එකට ඉන්නවා, එකට කාලා බීලා ඉන්නවා. So it's association. Right? It's association. But maybe your father has association with your company. Company. So it's a company. Because your father is an employee there. It's association. But for you indirectly depends on the company. Because the company so therefore, this is a dependency. Something like that. It's not directly you call, but indirectly you depends. Right? So let's take another example. Say this is your order class. Say this is your customer class. This is the order class. It's association because customer make orders. But when you make orders, all the orders are log logging class. Log කියන්නේ log file එක ලියනවා. Or you send an email, confirmation email. So that your order class call that method. So therefore it's association. Now your customer depends on the log functionality. Right? It's not direct. You don't directly call it, but indirectly you depends on its functionality. So then you call it dependence, like something like this. So this payment class depends on email utility. Payment doesn't directly call it. But maybe you call some other behaviors of another class, and maybe that class use it. So therefore, you also depends on that, right? So because this is the weakest, we just use this kind of a dotted line and open arrow. And in reality, most of the time, lot of classes depends on so many other classes. So therefore, most of the time you don't show dependency. But if you want to highlight a particular dependency as an important one, yes, you model it. Okay, you model it. Right. So this is the last one. Sorry, this is the last relationship between classes. That is inheritance. මේකනේ ගොඩක් අය දන්නේ. හරි. ඒක දන්න හන්දම තමයි අන්තිම ගත්තේ. Inheritance. So inheritance is one class is the subclass of the other class. Right. So the better word for inheritance in software development is uh, generalization and specialization, because that is the better word. Because when you listen to when you see the word inheritance, sometimes you get uh, misunderstand. මොකද inheritance කියන්නේ අම්මගෙන් පුතාට, අම්මගෙන් දුවට, දරුවන්ට. මෙහෙම දරුවෝ නෙමෙයි ඇත්තටම. Dog කියන්නේ animal ගේ දරුවෙක් නෙමෙයි. Savings account කියන්නේ account එකේ දරුවෙක් නෙමෙයි. Special case එකක්. ඒකයි මේ inheritance කියන වචනේ දැන් වැඩි පාවිච්චි කරනවා අඩු. Because this gives you a lot of misunderstanding. But at the same time, some of the concept of inheritance are applicable here. But the better word is, if you look at this way, it's a specialization. If you look at this way, generalization. So therefore, better word is generalization and specialization. So your savings account is a special case of account. Okay. Generalization, specialization. Okay. So this is, when you consider hierarchy, this is the superclass of these two. And this is the superclass of this one. And this is the subclass of this one. And these two are the subclasses of this one. And subclasses inherit non-private attributes and behaviors of the supertype or superclass. So the purpose is reusability, code reusability. And later, this hierarchy we can use for polymorphism. So remember, we can use polymorphism with inheritance, without inheritance. This is with inheritance. Without inheritance is use of interfaces. Okay, use of interfaces. The interview එකට යනකොට මේ ඔක්කොම දැනන් ගියාම මට පට්ට confident, right? පට්ට confident. දැනගෙන යන්න ඕනේ හැබැයි. ඉන්ටර්විව් එකට යනකොට ජොබ් එක ගන්න. අපි නම් යන්නේ එහෙමයි. So subclass inherit the non-private attributes and behaviors. And of course, your subclass can override inherited behaviors. Your subclass can introduce new attributes and behaviors. So, one කරන්න පුළුවන් නේද? Right. So anyway, we have discussed these things in semester one, okay? Overriding, adding new behaviors, adding new attributes. Right. So we have two type of inheritance, single inheritance versus multiple inheritance. So single inheritance means a class can have maximum of one supertype. Right? One. But if a class can have more than one supertype, that is called multiple inheritance. Multiple inheritance. So multiple inheritance, you know that has the possible side effect of deadly diamond death, ambiguity, whether it inherit from left side or right side. So that is why after C++, almost all the other languages, they have not supported multiple inheritance. Java, Python, PHP, they don't support multiple inheritance. Okay. Because single inheritance is most of the time sufficient. And if you really need multiple inheritance rather than class level multiple inheritance, you can use interfaces. Because in interfaces, it's a contract, pure contract without implementation. Right? Subclass need to implement it. Still, you can have inheritance, but maximum one. Okay, so we discussed this, the deadly diamond death situation. Right. So now we are into the next part, interface. Okay, interface. So what is an interface? So interface, what is the difference between class and interface? Anyone? Can someone tell me one or two or 3 points about classes and interfaces? Say you go for interview. So there's an interview question.
Interfaces are abstract.
Yes, interfaces are abstract. You can think of interface as an abstract class, not normal abstract class, 100% abstract class. So why do we say it's 100% abstract class? Because abstract class can have implemented methods. Right? It's abstract class, but still implemented method. Sometimes all are implemented, still you call it abstract class. But if it is interface, none of the method can be implemented. All methods must be non-implemented. Because the moment you implement something, you get into that deadly diamond death situation. So you just keep it for the implementer. That is why we say we implement an interface, realize an interface. We don't say that class inherit from interface. Class implements an interface. Java වල පාවිච්චි කරන්නේ implements කියන වචනේ. It's your task. So interfaces are 100% for the polymorphism. Interfaces have no connection with inheritance. Interfaces are not for inheritance. Interfaces are for polymorphism. But there can be inheritance between interfaces. Okay? Between interfaces. So interface facilitate polymorphism for classes. මේ ඔක්කොම කරලා තියෙන semester 1 වල. This is just a revision. So you must have only abstract behaviors and constants. Constants. There's nothing called instance variables in interfaces because you don't create objects of interfaces. So interface can use inheritance. One interface can inherit from one or more other interfaces. So that means if a particular class implements I3 interface, it must implement all the behaviors of I3, all the behaviors of I1, and all the behaviors of I2. Okay. And remember, when it comes to interfaces, multiple inheritance is supported. It's between classes, multiple inheritance is not supported, but interface level, multiple inheritance is supported. That means interface can have multiple super interfaces. Right. You can see does not support multiple inheritance for classes. However, multiple inheritance among interfaces are allowed. So this is perfectly okay. But if this is a class, this is going to be error. Okay. So when we implement the interface, remember class can implement the interface. So the word we use is realization. So we say that class 1 realize interface 1. No, class 1 implements, it's a dotted line, right? Not solid line. Uh, so we use the same arrowhead as inheritance, but not the solid line. Solid line is inheritance. This is realization or uh, implementation. Class 1 implements interface 1. Class 1 realize interface 1. So we say C1 implements I1. So then you need to implement each and every method here in your class. Override. If a class A realize interface I, it has to implement all the methods in the I and its super interfaces if any. Not only this, if this has super interfaces, you need to implement those methods as well because it's a contract. It's a contract. Right? Interface is a contract. You need to promise that I will implement these methods. Okay. So this is an interface loggable. It has a one method, and your payment has implement loggable. That means your payment can log. Payment can log its actions. Why? Your payment is a loggable. So that means you must have implemented the log method, log prompt method. So if someone call the log prompt method, someone must be able to call the log prompt method for the payment objects. That is what is meant by payment is a loggable. Payment implements loggable. So others can safely assume that payment object have the log prompt method because log prompt method is a method in loggable. So another class can say, or order class can say, I am also loggable, not only payment. That means order must also implement the log prompt method. It's a contract. Okay, so class can implement many interfaces. Interface can extend from many interfaces, but class cannot inherit from many classes. Okay. Right. Any questions? Any questions? Right.
So
Yes.
if interface inherit of multiple interfaces, so the problem can happen again, right?
No,
The
no,
double dimension situation.
no, because interfaces have not implemented anything. So that is why we don't implement in interfaces. So if it is implemented, only the problem is. When you don't implement, there's no problem. Because implementation is not done by the interfaces, implementation is done by your class. Your class. So therefore, that issue is not there. The issue is when implementation is in super types, then you don't know which one you get it. But now it's just a contract. It's a contract saying these methods must be implemented, has been implemented by me. So therefore, the issue is not there. Issue is when you implement. That is why we interface is 100% abstract class. So the issue is not by having the method signatures, rather implementing the things. So implementing thing is good for inheritance, code reusability, but bad for uh, contract obligations. Okay. Right. So now we move on to, so we'll continue without a break and stop at 12 because we just took only one break, right? Two breaks, right? Right. So we can classify classes based on its role or its functionality, right? And again, if you want more examples, go to the chat GPT, ask practical examples of using interfaces. Give me practical coding, Java coding, or use of interfaces. I don't know, it's a very good example. It just say payment method. Credit card payment is a payment system. So therefore it says credit cards is payment implements payment method. So that means your credit card can be used for payments because you are a payment method. So that means you must implement pay behavior the way you do it. Credit card do it. Okay. So then whenever there's a need for payment, you can create a credit card payment object and do the payment because the pay behavior is there. But maybe some customer will decide, no, I will not use credit card payment. I will use uh, bank transfer payment. So then bank transfer payment must implement the payment method. Okay. So then you need to just give me 1 minute. Right. Sorry for that. Okay. Uh, right. So therefore, now we can have multiple payments. In the future also, you can introduce another class, but make sure you implement payment method. So then your new payment method can be used in your existing system also. That is called open for extension, close for changes, open close principle. Right. And so you don't need to go and change that code, but you have introduced a new payment method to the system. Okay. So these are very serious stuff, very serious concepts. Okay. So this is just the starting point. So there are so many design patterns which we have not covered, right? Architectural patterns. So that is why software engineer, when you 1 year experience, 2 years experience, 3 years experience, your salary is getting increased because you know these concepts. That is why if you're a really good software engineer with about 5 years experience, maybe your salary is somewhere 700,000 rupees, 800,000 rupees. Okay. Some people even get 1 million. But that is because they keep learning these things, keep building these competencies. But if you can't even understand what is interface is, of course, you can't start your journey. Okay. So that is why we say it's capacity building. So if you don't have the capacity, neither. No point නේද කොච්චර පිරෙව්වත් අනිත් පැත්තෙන් ඉහිරිලා ගිහිල්ලා semester 2 එකවත් ඉවරයි semester 2 එකකින් එළියට යනවා දැන් sorry semester 2 වල කරපු database design එක දැන් කරගන්න බෑ guys normalization මතක නැහැ attitude තමන් ඔහේ කරපු මතක නැහැනේ මතක තියෙන ආසාවෙන් කරපු දේවල් purpose එකක් ඇතුව කරපු දේවල් ඉතුරු වෙනවා අනිත් දේවල් වල certificate එක ඉතුරු වෙනවා අනිත් මෙලෝ මගුලක් ඉතුරු වෙන්නේ නැහැ Right, so this is the classification of classes based on the role these that class play. So we can identify, this is again standard UML, boundary class, entity class, and control class. Okay, boundary class, entity class, and control class. So what is mean by boundary class? Boundary class means basically it's either it's a user interface or system interface. For example, say you have a JFrame class, which is a form, J dialog box. So that those are boundaries for user interactions. So then you can mark that class as a boundary class. So this is a special symbol we use for boundaries. Like අර බිත්තියට හේතුවක් දාගෙන ඉන්න මිනිසෙක් වගේ ඔළුවක් වගේ. එයා boundary එකට ඉන්නේ මේ boundary එකේ. Or it can be a system interface. Your system called another web service, microservice. So then what you call is the boundary class of that web service. Okay? Or that API. So boundary classes are either user interfaces or system interfaces. Or it can be even device interfaces like you are calling a sensor and so on. Okay. Right, so that is called boundary class. Then entity class. So entity classes are for domain entities like payment, order, customer. Okay. So most of the time what you have is entity classes in your system. Okay. In your system. So that is called entity class. Control class is, it's not a major functionality in the system, right? Customer, these are domain functionalities, customer, payment, order. Control classes just control the business flow, like payment process, order process. So there should be some controlling, right? Orchestration, controlling the flow and calling the relevant behaviors of the relevant objects, right? So those are called control classes. In MVC architecture, model view controller, remember we have the controller. So that control is a control class. Controller called remember we created a entity class. Okay. Uh, remember we did the UI part in PHP. So there we did not use a controller class. We use view and then model. So I told you the missing part is controller. So missing part is control. So we can introduce a control separately so that controller will do the overall control. That means extract the data from the view and call the entity or the domain class. Okay. So if you use MVC architecture like Spring Framework, Strut Framework, Laravel, so then you already, the framework provide the controllers. You extend the control and you code it. So then you must know what to do in controller class, what to do in model class, what to do in views. Okay. So what are the three things? Boundary classes, entity class, control class. Okay. So control class will control the process. Right? It is not going to interact with the database. It is not going to interact with the user. No, it's just the controlling. Your entity class will interact with the database. So it's a special type of entity class called persistence. Most of the time, entity classes are persistence classes or interact with databases. Right. So this exercise for you guys, you need to identify whether it's a interface, entity, or control. Okay, student, what do you think? Is it an interface? Here, interface means you not the normal sense, right? Interface means something like a boundary class. Okay, boundary class. So student is a entity class. Okay, student is a entity class. So inquiry control, obviously it's a control class. So new payment form.
Interface.
Yeah, this is here interface means user interface. Okay, user interface or system interface. Course
Entity class.
is a entity. Inquiry form again, interface. Payment,
Entity.
entity. Course management,
Control.
that is a control, right? Managing. Lecturer,
Entity.
entity. Course, entity.
Entity.
Payment process,
Interface.
payment process.
Control.
It's a controller. Okay. So I think this is all credit card payment. I don't know why we use the word call. Maybe credit card payment.
Interface.
Payment. I'm not also very sure. I don't know how it came here also. Uh, Credit card. It says call also. Yeah, maybe interface because it called this credit card payment. I'm not very sure about that one. Okay, or maybe control. Yeah, so maybe yeah, maybe because it's interface you are calling the control. Okay, so usually interface don't directly call entities. Interface call the controller, controller call the entity and get the results to the control and give the results back to the interface for the next UI. Okay, so that is how the MVC work. Right, our next subtopic is now we are done with class diagrams. Any questions about class diagrams? Because no point drawing modeling the class diagram unless you know what you are doing. That is convert diagram into code because ultimately no one cares about your class diagram. But at the same time, ability to model the class diagram is also important. But but that is not the end of the story. You need to convert that into code, software. Right. So this is a different type of diagram, but because these are highly related, they have put it into the same topic, package diagrams. Remember in Java, we discussed packages. Why do we have packages? Semester 1 knowledge. Why do we have a concept called packages? So number one, packages help us organize our code in a semantic manner. So related functionality code in one package. Order functionality related things in order package. Payment functionality related things in payment package. And so on. Okay. So second thing is, especially in Java, packages facilitate you to do access controlling. Remember when we say private, public, protected, right? So default access means only within package. Protected means within the package and outside the package if you have subclass. Private means only you. Public means regardless of the package, anyone can call. Okay. So therefore packages are important for better organization, access control and so on. So when you design your software, you need to decide what are your packages at high level. Later, of course, you may introduce new packages, but at the beginning, you must have idea about these are our packages. So then the relevant software engineers, when they create classes, they should know, okay, I should create this class in account package. I should create this class in order util package because this is utility for SMS sending, okay, and so on. But if you are developing it as a team, the team must agree this is our package structure. Should we introduce a new package? Or should I add my new class to this package? So in UML diagrams, UML package diagrams, it's a very simple diagram. So it shows packages, sub-packages, and dependency relationship between packages. Okay, those are the three things, right? So this is a package order, okay, and these are classes in order package, and this is sub package or inside order. This is another sub package inside order, and of course your sub package can have further sub packages. That sub package can have, right? That is why it's in Java also some Java util, right? In Java package you have util package. Right. So what are the relationship that we can show in package diagram? You can show the dependency relationship between packages. This is not dependency in classes that we have already discussed. So we can say that this package depends on these two packages. Sorry, not sorry, other way. This purchasing package depends on accounting package. Payroll package depends on accounting package. So that means purchasing functionality will not work without accounting. Payroll will not work without accounting, but accounting functionality will work without these guys because accounting does not depend on purchasing or payroll, but purchasing depends on accounting, payroll package depends on accounting. So that means classes in purchasing call behaviors in accounting. Classes in payroll call behaviors in accounting, but not the other way. Classes in accounting package is not going to call purchasing objects, payroll class behaviors, and so on. Okay. So basically dependency means actually it's the classes depends on. So then packages also depends. So therefore when you build this module, that means you need this module as well as a library. To build this module, you need this module as a library. But to build this module, you don't need this because they call you, but no, you don't call them. So your dependency is either unidirectional or bidirectional. So this is two unidirectional dependency. Okay. So this dependency can be of two types. What are those two types? Import, access. Okay, import and access. So the import means a particular package import the other package. Okay. So you know that you can have class A and there's an import statement of class B or package B, class B. So then that's a dependency, right? Your class A will not work without class B in maybe class B in package B. So that is import dependence. Sometimes you access it, right? You don't directly import it, but maybe you call someone else some other methods and that method calls that. So that means it's a weak dependency, but still you need it because you indirectly access it, right? You indirectly access it, but import is you directly access it. You directly need that package. Access means you indirectly need that package. Okay? But both are dependencies. Okay. So this is an example. Some dependencies. So this package access these two packages, this package access this package, and this package access this package. So access means dependency. Okay. So payment depends on utility. Order depends on customer. Order depends on payment. Okay. It depends on actual functionality. Okay. So you can't just look at this and say which one is depending on that. So it depends on it's actually when you are developing the software. Okay. Right. So that's it. Okay. Right. So that's it about class and package diagram. So now you must start doing MCQs. Okay. Start doing MCQs. Uh, shall we look at one or two MCQs just to get a feeling of that? Say last year. 2024, we don't have the MCQ paper. So therefore, we'll look at the 2023. Now you must be able to do half of this, more than half, okay? The questions. So this is, we have already done. Today we discuss these things, okay? So this is related to today's one, class diagram. Course offerings, lecturer, this is a role name, right? So now read this and do it, okay? Do it. And so this is something we have not done yet. Right, so let's do the first question. Which term from A to E is the most appropriate to fill the blank in the following statement? E is the process of combining data and methods that operates on the data within a single unit. How do you call this? E is the process of combining data and methods that operate on the data within a single unit. Anyone?
Encapsulation.
Yeah, that is encapsulation. Second one, rectangle and triangle are two classes having a method called find area. Though the name and the purpose of the method in the classes are the same, the internal implementation, i.e. the procedure of calculating the area is different for each class. When an object of class rectangle invokes find area method, the operation finds the area of the rectangle without any conflict with the find area method of the triangle class. In object-oriented paradigm, above is an example of what?
Abstraction.
Is it abstraction? In a way, indirectly abstraction is also there.
Polymorphism.
Yeah, for me, it's more polymorphism, right? I don't know if the examiner will take both the answers, but for me, it's more polymorphism, right? For me, it's more polymorphism. Right, third one, we'll check the answers at the end. Consider the following example. Dog is an animal, aircraft has engine, house has rooms. Which of the above example represent generalization, specialization? That is super easy, right? What is it?
A.
Yes,
A.
it must be only one. Because has a relationship is either composition or aggregation. Okay. So is a relationship is generalized. Now we can see the examiner also has not used the inheritance, rather generalization, specialization, because this make more sense. Okay. Right. So let's check these three answers. First one. Yeah. Yeah, it's BAA. BAA. Okay. B, A, A. Okay, so what about the fourth one? Exam එකට යන්නේ A එකක් A plus එකක් ගන්න තමයි යන්න ඕන. වැඩක් කරත් එහෙම වෙන්න ඕන ඊට පස්සේ. Consider the following statements. Which of the above statements related to object-oriented concepts is are true? Like you just need to check true or false. ඉස්සර question එක කියවන්න නැත්නම් ඔය කියවනවා. The type of polymorphism achieved through method overloading is compile time polymorphism. True or false? Then හොඳට
True.
වැඩි කරන්න.
True.
True? Anyone else?
True.
True. Because method overloading is compile time. Method overriding is runtime. Late binding. Late binding is method overriding. Right? So that is why we can introduce new functionalities later. Right? Without touching the original code. Right? As long as you implement that interface, right? So you don't need to go and change that. So I will take yes. B, second one, inheritance is a concept that allows you to create new classes by extending existing classes, and it defines an easier relationship between classes where the new class inherits the properties and behaviors of the existing classes called the base class.
True.
That is correct, right? That is correct. That is a very good explanation of inheritance. Third one, encapsulation is the core principle of building data and related methods together within a class, protecting data integrity and promoting modularity.
True.
True.
Yeah, we'll go all right. So we'll go for E. Yes, it's E. Okay. Right. So now you can get a feeling of what kind of questions they ask, right? So these are not easy questions, right? But if you have studied it properly, these are very easy questions as well. Right. So we stop at this point, right? Thank you.
Thank you, sir.
You're welcome.